PASQuanS is a consortium of academic and industry partners which is devoted to develop the European quantum simulators in a specific platform, namely atomic platforms. So what we have been doing in the last years and we are planning to do is to push forward the limits of what we can do with our hardware.
PASQuanS is about programmable quantum simulation, and programmable quantum simulation is something where we can use our atoms that follow the laws of quantum physics to simulate things that cannot be computed on a classical computer.
So the really exciting thing about PASQuanS is that we have a number of the very best people in the world in terms of both the theorists and the experimentalists. We have some of the leading experimental platforms in the world across a variety of different architectures, and it's very exciting to bring together people with different expertise. Also bringing in industrial partners that are providing new laser systems and technologies that will underpin future generations of these platforms.
I think quantum simulation is a fantastic field because it combines cutting-edge technology, really complicated big machines, pushing the limits of technical know-how.
I like about quantum simulation and the field of quantum technology in general that it has some nice synergies between the fundamental aspects of quantum mechanics and novel technologies which are on the forefront of what is possible at the moment.
So I'm a theoretical physicist, so my main research interest lies in answering questions in fundamental physics. And I think quantum simulation is great because it allows us to do that with tools of quantum technologies. So it's a completely new way to think about answering these kind of questions.
We want to continue extending the capabilities of the quantum simulators, trying to reach out more and more to applications where we have really hard to simulate problems, trying to reach a so-called quantum advantage, or at least drive the systems into regimes where we can deliver useful qualitative and quantitative input, which allows us also to advance some of the best classical numerical methods and compete with these.
What I can talk about is that we are advancing the enabling technology that's to be used for PASQuanS, and their spillover into other areas of quantum technologies as well. These things that we develop can also find uses in, say, quantum communication, quantum computation, also in sensing. And so while it is specifically targeted and we work in close collaboration with partners in PASQuanS and we are looking at their demands, it will help to create technology that can be used at a broader footing.
So in PASQuanS too, there are several industrial partners, and the way how we are working together with the researchers are to develop new quantum simulation technologies that range from the hardware developments, from building more robust and more reliable quantum simulation platforms, to software, to their interfaces, and also developing use cases. Use cases are especially important because that allows them to transfer the research results from quantum simulation to industrial applications. And so there are a couple of very good developments in that direction.
So industrial partners provide a key technology platform in PASQuanS 2.1 by offering solutions that have already been mature enough. So basically tools that are ready off the shelf. Industrial partners provide these tools, be it hardware or software, to the academic research labs.
We as end user, we have to develop the algorithms. We have to imagine the future usage of these machines. And I think that our role within PASQuanS differ a little bit from the role of end user in other European projects. We don't have to just put the use case on the cloud and wait for the answer. We have to develop them.
But so our goal is to develop workflows to do more and more of the engineering work virtually on a computer, which means we want to integrate as many capabilities as possible. So be it AI method, be it quantum methods, and so on, and develop them into a complete workflow, which then allows us to speed up our engineering tasks significantly by doing them on the computer instead of doing trial and error, doing experiments, and so on.
So we are somehow like computer industry in the 40s, so we have big, large machines with limited power, but we are, working very, very hard to have a fast development, and that so soon these things will have an impact for all, Europe and all our both academic and industrial practical problems.
I think the bravery to do something else and try new stuff, even if it fails at some point.
I hope that the insights young researchers give are shaping the future of this field. They enable new cool features, new cool applications for the science we're doing here.